Hey everybody, Lars here. Time for the very last review video that we're going to do for Big Bad Unit 3. First section of Unit 3 we went over functions. Second one we went over some stuff with file I/O. And this last one we bring it all together by looking at modularity and libraries. We're going to do two things tonight. The first thing we're going to do is I'm going to bring up a program and we're going to play around with some standard library stuff. And then after that, I am going to do a homework of my very own that is similar in many ways to the homework you're going to have to do for this particular unit. Shooting this 7:30 Friday night. We'll probably release it to you either super late tonight or tomorrow morning. Before the Rutgers game, I'm not going. I'm still sitting here in my cast. My orthopedist's father passed away, poor guy, and he canceled all his appointments this week, so I am not getting my cast removed until early next week now, so I have to spend another weekend limping around like a crazy person, but that's all right. I will release the homework assignment when I release this video, so it might be a good idea to just go give it a quick scan to know what you're up against. And then you could go, oh my God, this is crazy, blah, blah, blah. But then when you see me do my little homework assignment, you're going to see that structurally and a lot of things we do are similar to what I'm going to be asking you to do. So hopefully it'll be a good guide for you, or at least a way to see some things done and maybe remove some of the trepidation from the assignments for Unit 3, okay? So let's go look at some code. This is a coding class after all. So here, I just started up a simple program, created a list, and I'm going to print out the sum of that list. So let's just run that baby and see what we get. All right. And I get nothing because I didn't print it. Always a good way to start out with insanity. Let's see. There we go, 362. I'm assuming that's correct. I have no idea if it's correct. All right. I have 362. What if I wanted to sum up that list and find the square root of the sum? I could say b is equal to square root of a, and then print b. Now, what do you think is going to happen when we run this little piece of code? I'm going to run it to show you. Boom, we explode. And the reason we explode is that Python doesn't have any earthly idea what a square root function is. We didn't define it like one of our homegrown things, and we don't really tell it to go look somewhere for it. And this is the first time we're going to be talking about using code, and I'm going to do it on Google just to show you how easy it is. Python docs standard library. Boom. And you're going to see the very first thing that comes up is the Python standard library page from the documentation. And this is worth its weight in gold. The story behind this is that Python has an incredible amount of code that comes along with it. You can see here there's functions to deal with exceptions. That's when we have errors in our programs. Text processing, different data types that we can use. We'll learn about some of them later. Numerical and math modules, directory access. It's the list. Look at all this code. This is all there for you to use. And the reason it isn't built in is because if you loaded all of this code into RAM to be ready to use in your Python program, Python would be huge. It would be monstrous. If you have any experience with the programming language C or C++, back when it was first formed in the early 70s, part of the design of it was to keep it small and to keep it portable. And if you wanted to use something like a math library or something like that, you would just import it and then use it, and then you could get rid of it. So Python, because technically in the background, Python is using C to do what it needs to do. That's a little beyond the scope of this particular course, but Python does a lot of C stuff. Actually, we're going to talk about that in another couple of minutes. So in order to stay lean and mean, Python just loads the basics, the basic keywords. You can iterate, you can do, simple data types and things like that. But if you want to do more complex things, you need to load the library in order to do it. So, frankly, that's what we're going to do. The way we do that is I happen to know that there is a library called math. and I'm going to import the math library. So I'm going to tell Python, hey, go look in the math library when I ask you to get the square root. And I happen to know, and look at beautiful idle, showing me all of the functions that are now available to me in the math library. We'll do it again. Do it again for me. And of course it won't. So now if I run this code right here, it tells me 19.02 blah, blah, blah. So that's the square root of 362. Now I happen to know that math also has another nifty little function called ceiling. I think it's I. Is it I or is it E? And there it is because it's telling me. And if I want to do that, I can just then print C. And we can take ceiling and make it a 20. Ceiling rounds up. So if you ever want to take your numbers and round them up to integers, you can do that. There is also a joining function called floor, which will take it down. Okay. Now, math isn't the only library. There are tons of libraries. And if you go to the standard library and look at things, it will tell you, what if I wanted to print, let's get rid of all this stuff. What if I wanted to print the mean, let's say, of that list? I will say B equals statistics dot mean of my list. Give mean and iterable, and then print B. So the mean of all of the numbers in that list is 45. Okay. We can also wrap this math.ceil in a ceiling call, and then that'll just be made of 46. Okay. So we're using the math library and we're using the statistics library. There's one other thing that I am going to show you. Actually, two other things that we're going to cover. The first is this, and I usually don't do this, but I am going to show it to you anyway. I'm going to say from math import ceiling, and from statistics import mean. Now what I've done there is I've changed the way I've imported. I've told Python, hey, go to the math library and get the ceiling function. And when you see ceiling in my code, go to the math library and get it. Same here. I want to import the mean function from the statistics library. And when you see mean in my program, it means I want you to grab it from statistics. It associates these functions with their libraries. And because I've done that, I now no longer need to list the library in front of those particular functions. So now I get rid of that and I just call mean and ceiling, but because of these particular imports using the from, I get the same response because I don't have to put the list in front. Now, what I always say is that I prefer to do it the other way. I prefer just to import the library, and then when I'm going to use something, I type the library name in front of it, because with these simple little toy programs that we use to learn, it doesn't really make a difference. But when you start writing real code and you've got 100, maybe 150 line piece of code, and you're down near the bottom, I could call ceiling and a programmer reading my code doesn't know where I'm getting it from. Did I write my own ceiling? Am I going to the standard library and I used a from import? What am I doing? If I just do an import and specifically leave that library name in there, then I'm telling the next programmer who reads my code exactly where I'm going to get it. They're going to go, oh, Lars is going to the math library and he's grabbing the square root function. Oh, Lars is going to statistics and he's grabbing mean or standard deviation or something along those lines, okay? Now, probably an old-fashioned way to go about it, but it's the way that I code. That said, I don't care what you do. If you want to use from and then import, go crazy. You will not be penalized in an assignment or, a quiz or something along those lines. Either way is fine by me. But me, being an old school guy, I do it the old-fashioned way. I just import the library, and then I put where I'm going to get my function in the actual call itself, so some other programmer down the line can read my code. Because readability is a big thing in Python. Big thing about Python is to, make the code readable so that programmers know what you're trying to do and how you're trying to do it, okay? One last thing we're going to go over is a neat little feature, but there's kind of a trick. So you see I'm importing from math and from statistics, and if I go to the listing, I can, where is it? Data persistence, blah, blah, blah. I can go to the math library, and I can see, oh, there's ceiling, there's factorial, there's all kinds of neat things, and when I come down here, I see my square root. Oh, that's really neat. It would be really cool if I could see the code that runs this stuff. So it turns out that this code is actually sitting on your hard drive. I go to the root of my particular Windows installation here. It's a Windows 8.1. And I go to Python 3.4, which is where my Python 3.4 is, and I go to capital LIB, and I have down here a list of all the libraries. And this is where Python's going to look for these libraries. If they don't find them in your home directory and they don't find them in that special environment variable that's defined called Python path. This is actually the third place Python is going to look. And if you're using a standard library, it's where you should find these things. So if I went down here to the end of the list, I see statistics. And I double click on it, and that's the statistics library. So if you're interested in knowing how Python is doing these functions, they're here. And when you become a more sophisticated programmer, you can come here and you will know what all this code does. Okay, so it's a good way to learn. It's a good way to dig through Python and learn. But there's a small rub, and it's the last thing we're going to talk about. We just looked at statistics. Oh, that was really neat. Let's go look at math. Math isn't here because the math library is not written in Python. There are a group of libraries, which is a little confusing because of the name, but they're called the built-ins. The built-in libraries are a way that Python allows us to use C code. Okay, so math library I know is one, sys, which allows you to do operating system calls and things with your operating system. That is also written in C. There are a bunch of libraries that are built-ins that are written in C. And you can go examine the source code because it's there, but it gets a little confusing, and I don't want to really go down that road. I don't want to tell you, hey, if you want to look at the code, look at the code, and then you guys come here looking for math and you can't find it. Math is one of those special libraries that's called a built-in library. It's not like the built-in functions like, sum and power and int and all of that stuff, but it's a built-in library where Python automatically says, okay, when I see import math, I know I'm going to use pre-written C code that's sitting in this special location. And that special location, I know I don't want to hide anything from you guys, is going to be in what's called a DLL library, because when you have code off to the side that we use for the operating system, Windows is written in C. We use things called DLLs, which are called dynamic linking libraries. And those libraries is where the object or already compiled C code is for a lot of the math stuff, okay? We haven't really, I know Zell goes over it a little bit in the book, but we haven't really bogged ourselves down with the difference between interpretation and compiling. But C is a compiled language. You create your program, and then you compile it. You create the ones and zeros that the computer understands, and then run that as your program. That's a little different than what we're doing with Python. Python is an interpreted language. So Python is going to run your commands one by one as it examines your code. Later down the line, you're going to learn that Python can be compiled if you want it to be compiled, and then things run a lot faster because object code runs faster than code that needs to be interpreted every time you run it, okay? All right, so that's the last thing we're going to go over. So don't make yourself crazy going, if you have a Windows system and you go to your lib directory or you do something else, in Linux it'll be a .so file where all that math stuff is. Don't make yourself nuts. That said, if you go look in this directory, there's a lot of stuff that you can go look at. So if you want to go examine the code and see how all that stuff is written, it is there for you, okay? And don't forget this. Don't forget the online resources. This is the Bible. This thing is great, all right? All righty, Rudy. All right, so you know me. I'm going to stick this up for us at the end of the day, and we are going to have it to look at. Now, the important part of this particular video is I am going to give myself a homework assignment, and I'm going to time myself. So it is now 7:48. So let me remember that. Actually, I'm going to write it down. 7:48. And we now are going to do a homework assignment. And I think the homework assignment I'm going to give myself, and I'm cheating a little bit because I've given it to myself in the past, but I want you to see it, is that I am going to take a list of 1,000 random numbers, and I'm going to read those numbers in to my Python program, and I am going to examine all of them to see if they are palindromes. Now, if you don't know, a palindrome is something that reads the same way forwards as it does backwards, okay? So I'm going to be looking at numbers. So if I get something like 1111, well, that's a palindrome because it's the same forward as it is backwards, okay? If I've got 2211, well, that's not a palindrome because 2211 isn't the same as 1122, okay? 131, palindrome, reads the same forward as backwards. Well, what I want to do is my boss is going to give me a file of 1,000. Add this to the list of things that are never going to happen in your life. But my boss is going to give me a file with 1,000 numbers in it. And he's going to say, Lars, you better write me a program that detects the palindromes and then adds them all up and gives me their accumulated value. So that is my homework assignment. Okay? I've already wasted a minute explaining it. So it's the first thing I'm going to do. First thing I'm going to do is I needs me some data, so you are going to get to see another secret. If you ever become a computer science instructor, you are going to go to random.org, and it is going to become your best friend. Because this is where you come to get the random numbers. I'm going to go to integers. I want to generate 1,000 random integers. They should have value between 1 and, I'm going to say, 10,000. And don't get crazy on me now, guys. And I'm not going to format in 5 columns. I'm going to format in 10 columns. And then I'm going to get my numbers. Got my numbers. And look at this. Boom. That fast. Random numbers. Yee-hee. Look at that. A lot of them. All right. Not doing me a lot of good sitting here on this web browser. So I am going to grab the first number there. I am going to highlight to the bottom of the list. I'm going to control copy to copy, and then I'm going to jump into Notepad, and I'm going to paste them in there. Look at that. Got me some numbers. All right, and then what I'm going to do is I'm going to say save as, and I'm going to go to where I'm keeping my code. And I cheated a little bit because I have files ready and waiting for us. Let's see, Python Data Science, Fall 2016, Unit 3, Homework, my homework. And I'm going to call this particular file rnums.txt. Bink. And I'm going to save it. So now we've got our data in a file. Freshly gotten random numbers that we are going to use in our program. Okay, so I've gotten my file that my boss is going to give me. So what's the first thing I am going to do? I think, and let me go show you. Python Data Science, Fall 2016, Unit 3, Homework. And right there you can see rnums. It's right there. 5K worth of numbers. And then all the different programs, you're going to see them in a second. But I'm going to leave that open right now. So the first thing I'm going to do is, I think I'm going to create my library. And I'm going to name my library tools.py. You see, I didn't do a lot of cheating. I didn't write a lot of code before this. And what I want in tools.py is a function that detects whether a string is a palindrome or not. And you are about to discover why I do this. Because there's a neat trick in Python that lets you do it in one line. I'm going to write a function. I'm going to call it isPal. Usually if we write functions that determine whether something is something or not, we call it is, like we're asking a question. So when we read our code, we go isPal, and it'll come back true or false. So I am going to write a function called isPal. I will call my variable ppal for a potential palindrome. And it's going to be a string. And as you'll see, our numbers, when we read them from the file, will be strings. So that's going to work out for us. And now, what do I want to do? I have a string. It's called ppal. I want to know if PPAL is a palindrome or not. So I want to know if PPAL reads the same way forwards as it does backwards. So get in your time machine and go back to Unit 2. Think about some of the things we did with strings, some of the things we did with slicing, okay? And then watch this. I will say if PPAL is equal to PPAL, but I'm going to slice. I'm going to say beginning, end, but go backwards, okay? And what does that do? Think about it. PPAL is just a string, but the sliced one, PPAL, is the string backwards. So what am I testing there? I'm testing if they're equivalent. So if the string forwards is equal to the string backwards, well, that's the definition of a palindrome. So that's going to tell me if my string that I've given to my function is a palindrome or not. So I did that if statement right there. What do I want to do? If that's true, I want to return true. Else, return false. This is a binary condition. You are either palindrome or you're not a palindrome. Okay? Now, one last thing we're going to do, just for S&G, is I am going to, you know what, I did good before. I got to do somebody else. What am I going to do? I am going to do, no, you know what, in honor of my buddy Cliff, I will create a variable called Carter, and I will make it equal to 8. Okay? So I have a file right now. It has a function in it called isPal, and it has a variable defined called Carter. Now, even though this is going to be a library and there's not going to be code to use, I'm going to test it while I'm standing right here. So I'm going to say print isPal, everybody's favorite little palindrome race car. And when I run this, hey, it comes back true. Okay? So now I'm going to stick a number in there and mess things up. And when I rerun this, hey, it comes back false. All right, now I want to do numbers, to be honest with you. So I'm going to see what that comes back with. And that is true, and it is. 11311 is a palindrome. But now if I mesh things up and I put a 2 in there, hey, it's false again. Okay, I think we've got this palindrome thing working. Okay, but I'm not writing everything in here. I'm creating a library. So I'm just going to zotz that out. And I have a file called tools.py, and it defines a function, and it defines a variable called Carter and makes it equal to 8. All right, that's it. I'm saving this. I'm popping this back down. All right. For those of you scoring at home, it is now 7:56. So we are a cool 8 minutes into our homework assignment. Let's try to make more progress. I created another file. It is called pals.py. And what pals.py is where I'm basically going to get most of my work done. This is a comment. Now, what was I told to do? I was told to take a file of 1,000 random numbers and look at them to see if they are palindromes, and take the palindromes and add them all up. So, what's the first thing I got to do? First thing I think I'm going to do is my file IO. I'm going to read in that file. I'm going to read, I'm going to open, I'm going to read, then I'm going to close. So, what do we do? In file equals, call it rnoms.text, right? All right, Fat City. Now, I want to say if. I want to make it equal to open in file and open it for reading. Done. Then I'm going to have a string variable called data, and I'm going to make data equal to f.read, comma. I would have spent forever finding that, huh? f.read. Beautiful. And then, as we all know, I am a good file IO citizen. So I am going to remember to close my file. You know what? Done. Out of the file IO business. Now I have a string called data that has all my data in it. Look at that. Read it in. And it read it in the same format that we saved it in. Okay? So now I'm done with file IO. I got my data. All my data is in that string right there. Now I can work, to clean it up and get things going. One thing I'm going to mention, though, because we're about to use it when we clean things up. We are not regular people. We are Python programmers. So your regular person sitting at home, eating bonbons, watching Oprah, eating Cheetos, playing scratch-offs, that person sees 10 columns of numbers, okay? We're not that person. We are programmers. So what do we see? I see a number and a tab. Number, tab, number, tab. All the way down the line until I get to the end, and then I see a new line. Number, tab, number, tab, number, tab, tabs all the way down until I see a new line. New lines all down here, tabs all in here, okay? Because they're characters. Those aren't just random spaces, those are tabs when the columns were created, okay? So we are going to use that information because we are clever people. We are doobies, not don't-bees. So what's the next thing I want to do? Next thing I want to do is I want to clean my data. So what's the first thing I'm going to do? I'm going to say data equals data dot replace. What am I going to replace? What am I going to replace? My goal here eventually is to do a split. So I need a delimiter that I can split by in order to take all of these individual numbers and put them in a list. But my issue here is that I have two different delimiters. I've got tabs separating my numbers in my rows, but at the end of a row I have a new line, which then brings me down to the next line. There's no tab in there. So it kind of messes things up for me a little bit. So what do you think I'm going to do? I'm going to replace those new lines. It's just a character like anything else, \n. And I'm going to replace them with tabs, which are denoted by \t. Okay? And then watch this. When I print data now, look at that. No more new lines. The only thing stopping me from going all the way across the screen with 1,000 numbers is the way things print to the screen. Okay? There are no more new lines. There's nothing but tab, 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 nothing but tabs all the way down the line, which is fantastic for our purposes. Because what are we going to do next? We're going to say data equals data dot split. Now remember the split function or method takes a delimiter. And we're going to give it t. So what split does is it returns a list, and it takes a string and makes everything an item in a list that is divided by the delimiter, in our case tab. Okay? So now when I print data, now I have a list. Okay? You can see the brackets, and you can see that I've read in data from a sequential file, which means that it is a string. It's not a number, but that's cool because I'm testing for palindromes. And basically my palindrome function as I wrote it, looks for strings. So I'm good here. And I'm going to show you a little trick down the line, and we're going to make them all integers, and we're going to do it really fast. So now I have a list of the string value of the numbers in that random file. Well, that is perfect because that's exactly what I need. So now what am I going to do? I'm going to iterate over the list looking for pals or palindromes. Okay? So what am I going to do? I'm going to do one thing first because now I know I'm going to do it. How am I going to determine if I have a palindrome or not? I got to use my isPal function. But right now, this program doesn't know where it is. Now it does. Import tools. Okay? Tools isn't in a standard library. Tools isn't, something that comes along with Python. We wrote it. There's tools right there. That's a custom library that I wrote, and you're going to write your own. Okay? So I'm importing from tools. So now, what do I want to do? For I in data, no need for range. I'm iterating over a list. If tools.isPal I equals true, tour, then what? Then I have a palindrome. So I'm going to say, I'm going to click a counter. I'm going to add things to an accumulator. And if I ran this code right now, it would blow up for two different reasons. What are those two different reasons? Number one, I am starting things on the right to the left, so I need to make sure those variables are declared. And if I accumulate A and try to add a bunch of strings together, it'll work, but it'll concatenate them. It won't add them together. I want to make sure I cast this and make sure that this is an integer. Then I will truly get what I want, which is the sum. Okay? So now, actually, you know what else I'm going to do? I'm going to print it. Okay? So now when I'm done, print. There were C palindromes, period. Their sum was A. Boom. Okay? Now, where am I sitting? Iterate over the list on the values. Give it a go. Look at that. There were 24 palindromes, and their sum was 53,134. Now, do I know whether that's correct or not? I don't have the first idea. But I'm heartened when I look up at my list, because look at all these numbers. 303, 656, 181, 616. They're all palindromes. There's 11. Okay, what's something this data tells us? This data tells us that there were no single digits in that number file, because a single digit by definition is a palindrome, but I don't see any here, so there were none. 202, 1001, all palindromes. Okay, and what I did was, by using my isPal library, I loaded in that isPal thing, and I just went through a loop, and I said, if it's a palindrome, print it, click my counter, and accumulate it. And then I printed them out at the end. Ladies and gentlemen, there's nothing in my hands. There's nothing up my sleeves. The time on my computer is 8:05. My superior math skills tell me that we did that in 17 minutes. 17 minutes. Okay? Did you look at your homework before? I mean, this is it. This is your homework if you think about it. We read in a bunch of numbers from a file, and then we used pre-written code that we had in a library that we wrote ourselves, and we processed the data. Now, you're going to do something different. This is the whole tool chain, if you think about it. Where are my numbers? Where are my numbers? Open. All right, there's my numbers right there, okay? There's my pals. All right, there's my tools. This is it. This is the whole tool chain right here. I had a bunch of numbers in a random number file. I read them in, and I used a pre-written library. I used tools in that to review everything in that file, and then I printed out the answers that I found. We're going to make this more Pythonic in a minute for people who are screaming, I would have done this, I would have done that. I'll show you in a couple seconds. Calm down. Okay? Now, if you've read your homework assignment, I'm sure you'll come back to this video a bunch of times, so I can talk about the homework now. You're going to have two functions. You're going to have harshed, and you're going to have siete. Okay? So you're going to have an extra function in here. You're not just going to have the one. You're going to have two. And you do have to do a little bit more file I/O than I did, because if I'm not mistaken, the results of the siete, which is run after you run harsheds, needs to be sent to an output file. So you're going to create an output file, and then you're going to go through the process of populating that output file with the numbers that come back true for your siete. Siete, I believe, looks over all the harshed numbers and determines if there's a 7 in the second column. Okay? And that's it. Now, the last thing you're going to do when you do your homework assignment is you're going to deal with a constant variable, and you're going to use it for the third part. I just defined a variable here called Carter. And if I came in here and I said print tools.Carter, boom, it prints 8. See an 8 anywhere in here? No, it's a constant that was read out of a library, and that's useful sometimes. Okay, so that's it. I mean, that's the bottom line. there's actually these 2 more things we're going to do. But look at, this is the tool chain right here. You know how to go I'm going to give you the random numbers, so you don't have to even go and get them. But here's the raw random number file. Here's a program that read them in, okay, cleaned them up so that I now have all the numbers as individual items in a list, and then I iterate over that list using my pre-written library. 17 minutes it took us. No time at all. All right? Now, the whole point of all this is I'm going to say, nah, do I want to say open? I don't think I do. I'm going to say new file, right? And I'm going to put in my comments because I'm a good programmer. I'm going to say import tools. And then I'm just going to say A equals race car. Print is pal A. And what will happen? That'll explode because I need to tell it where the library is. Okay? So now when I run this little piece of code, it's going to ask me to save it. I'm going to save it, I'll just call it test. True. Okay? Let's change the race car. Put an 8 in the middle. Still true? Nope. False. Okay? What's the point of this? You don't see any palindrome code in here. Okay? It's already written. It's already sitting there. I can use it wherever and whenever I want, as long as I import my tools library. And you'll learn when you start programming, programmers will come up with a function or come up with a little piece of code that they like, and they'll create a function and they'll put it in their library. And they'll call it tool. I always called mine tools. That's why you're seeing this. And then just, you know, back in the day when I was a C programmer. So what I would do is I had a header file in C called tools.h, and I just imported that. First thing I ever did, well, first thing you do is import stdio. But after you do that, I would import my tools. And then I would have everything that I had pre-written that I had always done, that I always needed, be it string formatting, be it mathematical things, be it something specific to what I was doing. If I'm writing code for accounting, maybe I want to differentiate between, you know, income or expenditures or equity or things along those lines. If I'm writing scientific code, maybe I want to do something special with complex numbers, so I want to separate out the imaginary from the actual and blah, blah, blah. I mean, you can do whatever you want. Save it in your own libraries, okay? So that's what modularity is about, okay? I'm using this in 2 different places. I'm using this in this silly little test pie, but I'm also, right. But I'm also using it here where I did my homework. My little homework assignment, okay? So that's it. One last thing I think we're going to do, because it makes me nuts. Counter, accumulator, counter, accumulator. You don't really need it anymore, do you? Do you? I'm going to create a list called pal list. It's blank. If it's a palindrome, pal list.end. We are using parentheses this time. AI. So now I have pal. So if I want a count of the pal list, what do I do? Oh, you know what? I need it. Okay, you ready? You're getting something else here. So that's done. So now I have a list called pal list, which is full of my palindromes. I am going to create another list called int list. An int list here, you got another one. 4 days, you got 2 list comprehensions. That is the one-line way that you take a list of strings and turn it into a list of integers. Okay? Just do a quick list comprehension. I want to cast for all I in pal list. Boom, done. Now, int list is a list of integers, which is kind of what we need, because what we're going to do, and we can even use int list down here, is I'm going to say len int list, and that's going to give me how many palindromes there are, and then the sum is going to be sum int list if I want to add them up. And that is most indubitably a more Pythonic solution, exactly what we're going to do. When you want to it's data science. When you want to separate things out, put them in a new list so you have that list to play around with, okay? And then real quick, we can just turn it into integers because we know we want to do arithmetic on it. All right, let's lose the tools.carter. Put that there. Look at that. Mean, lean, code and machine. 24 palindromes. Sum was 53,134. Sounds familiar, doesn't it? Okay. More Pythonic way to do it. When you find something, remember what counters do. Remember what accumulators do. Remember how to code them. But we're Pythonistas, so we set up a list. When we get our data, we stick it in another list, and then we manipulate that list. And if you need a counter, it's just the length of the list. It's how many things are in there. And if you need a sum, you just sum it up. You make sure it's an iterable, and you make sure that it's an integer, that it can be added up. And we did that real quick here by creating a list. And we took our strings and we made them integers using a quick little list comprehension. Again, you don't have to use list comprehensions. I'm just showing you how to do it because it's what I do. And it's a nifty little one-line trick. If you have a list of strings and you want to turn them into integers because you're going to do, data processing with it, that's one line, and all of a sudden now your string list is now an integer list. Okay? So, boom, right there. All right, you ready? I am not going to put this code up on the web because it's your homework, basically. Much of the structure, much of the things it's doing is your homework. So, in the vein of learn Python the hard way, you are typing it in for yourself. You're welcome to look at this. You're welcome to see how I did it, how we discussed it, the different structure of things. But I am not going to put this up on the web. I will put silly, doofy little Scratch up there. I think I got rid of it, where we first did the import for the functions. That I'll put up on the web. But all this stuff, nah. You got to do it for yourself because it's your homework. And it's good. It's the way you learn is by typing yourself, because when you type yourself, then you're thinking about the logic and the flow of the logic, and then you will undoubtedly make a mistake. And there is no better way to learn computer programming than correcting your own mistakes. And you can get the benefit of doing all that stuff, okay? So this is libraries. This is modularity. Again, this is the end of Unit 3. All right? Look in the mirror. There's a Python programmer there. We've gone over the basics of imperative Python. You're done. Now, moving forward in this particular course, you're not going to be learning Python as much as you're going to be using Python. We're going to take Python. We're going to look at computer science concepts in Unit 4. Unit 5, we're going to look at something called object orientation. It's a different way to organize how you do things. But it's still the same. You're still going to have variables. You're still going to have data. You're still going to have functions. We're going to call them methods. You're still going to have a whole bunch of different things. We're going to introduce a couple new concepts, but it's, going to be the basics of what you've been doing already, iteration, sequences, things along those lines. All right? This is Python. You know it. It is now, 6 weeks we've been doing this. And you basically know the basics of Python right now, and that's the secret of this course. Everybody takes Python for data science, and they think within 2 weeks we're going to be importing pandas and NumPy and doing, matrices math. And you got to learn to walk. You can't just come in crawling and say, I want to do blah, blah, blah. You got to learn the language first. You know what? You've done it. You've done the work. You've hit the big basics. You're reading the Zell to fill in some of the other cracks there. Your midterm assignment is, there's always a method behind my madness. And the reason I have us do that midterm assignment is because you're getting extra practice. You're listening to somebody else's early view of Python and Python programming when you look at those MIT open source videos. You are doing it for yourself when you use Learn Python the hard way and typing in all those programs and making them work. Code Academy, going through those things is where you get your hand held online and do some things. That is a good segue into announcements, because I will let you know that it is now the 14th. Keep in mind, November 4th is the due date for the midterm. So please get going with that, okay? Engage with those resources. MIT open source videos, Code Academy, Learn Python the hard way. Because if you think about it, from a pedagogy standpoint, all three of them come from different areas. And I'm very curious to know, when you guys write your reports, about which you prefer, what you like, what you don't like, what are the pros and cons of each one. And I always like reading those reports. I like this midterm assignment because I like reading the reports and I like seeing what you guys think about it, because you guys are graduate students. So you're not going to give me some 19-year-old, I like this, it was fun, I did. you're going to give me real answers from someone who already has an undergraduate education and kind of has that meta idea of how we teach and why we do different things. So I'm always curious to know what graduate students think about the different methods and pedagogy that's used when they take their courses. Because, when you get on to graduate school, it's next level stuff. I usually don't say stuff there, but it's next level stuff. So you start getting curious about, why am I doing it this way? Now I'm reading 3 papers per week, and then we're coming in and talking about it. How is this better than what I used to do, memorizing facts and regurgitating them for tests and things along those lines? It's interesting. It's really cool to do. Keep that in mind. November 4th is that midterm project. Second reminder, group formation. It is 3 days from the 17th. On the 17th, if I have not heard from you, I'm going to create groups. And it's a very, very complex algorithm that I use to create groups. I'm going to alphabetically go down the list and go, group 3, group 4. Okay? So, oddly, it usually works because you guys are in graduate school. You guys take things seriously. You're all looking to do well. You all work well with others. So that, you know what? If you don't know anybody and you don't know about making a group, don't worry about it. Just roll the dice, get your group, and then start talking to each other. For whatever reason, in the past, whenever I've done this, and this is what, 4th, 5th time I've run this course, there's always a coder in the bunch. There's always someone who's good with design. There's always someone who comes up with a decent idea. And when I announce the final project, I will put up examples from previous semesters. So you guys won't be, swimming in the ocean without a life raft. I will give you a couple of life buoys, so that you can see what other people have done and see what's expected. Plus, you'll get a rubric and everything will be all right. I usually don't like to release final project information before the midterm is done because I want you working on that midterm. But November 4th as a due date for the midterm, I don't know, and my brain seems a little late. So I'll probably get you all the final project information the last week of October if you promise me to work on that midterm and just, read it over real quick for informational purposes. Anyway, I'm getting far ahead of myself. My thing with you is in the next 3 days, if you have a group of people you want to work with, create that group. Send me an email. Let me know what you want to do, and I will let you create that group. I'll tell you right now, I already have one group. It's a group of 5. They got in touch with me really early in the process. So one of the groups of 5 is already gone. If you want to create a group of 5, let me know, and I will try to hook you up. Okay? All right, good. You will be getting this on October 15th. The unit ends October 27th. So with 12 days left in Unit 3, you have all of your resources, slides, Zell readings, 3 review videos. And as of tomorrow, you'll get your last video and you'll have your assignments. Okay? So you have 12 days. Hopefully, you have already steeped in the slides and the readings and looked at some of the videos. Then you'll be able to watch this video, see the assignment, and get going, get building some stuff. Don't forget that forum post, okay? Don't forget to look over the slides and be ready for that quiz. So the quiz, open day book project, blah, blah, blah. But if you do a little studying beforehand, you'll spend half the time on it, okay? You've already taken 2 of these quizzes. Not the hardest thing in the world, okay? Not the greatest shakes. So you got no worries as far as that's concerned, all right? I know I probably went long on this video. What, 7:48, 12 plus 22, so I'm over a half hour already. Not a big deal, though, because this one's good, this one's informative, and this one's going to help you. So, what was I going to say? I think what I was going to say is that don't worry about the quiz or anything at the end of this unit being cumulative as far as the first 3 units. I'm only going to quiz you on stuff from Unit 3. But think of the first 3 units as a whole, because they are. That's the way I designed it. I designed it to get you the basics of imperative Python in the first 6 weeks of the course. Now, we're going to go use it. We're going to do some computer science. I'm going to teach you about object orientation because you really do need to know it nowadays. when you use third-party libraries and other people's code, it's all object-oriented. So you're going to want to know those things to read it and do it. And then the last unit, we're going to look at some data structures. We're going to look at some more computer science stuff so that when people talk about that, you'll know that kind of stuff, okay? Moving forward, the assignments, they're going to be more data science-y. There's going to be some extra credit with some data science stuff in there. We, next unit, are going to play around with a third-party library called Matplotlib, which is basically MATLAB for free. And it's very popular as far as data visualization is concerned with Python programmers, okay? We're going to make you aware, I don't know how much we're going to work with them, but we're going to make you aware of that data science toolkit in every Python programmer's brain: SciPy, NumPy, Pandas, sklearn for machine learning, blah, 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 blah. You're going to start getting that stuff. You're going to start, at least referring to it and knowing what it's all about. And we're going to get you all trained up. You got no worries, all right? Then you have a great weekend. I'm getting out of here. Hopefully Rutgers does okay tomorrow. I'm not going to the game because, like I said, I'm still in this stupid cast, at least until next week. But hopefully they do okay. I will be trolling around the forums. You know me. I will be a pest with the announcements, and I'll be hitting you with deadlines every other day and letting you know what everything is going on. And if you have any questions, ask. All right? You be good. You have a good weekend. I am out of here. I will talk to you later. Bye-bye.